Okay, today we're talking about rational exponents. So yesterday we were talking about exponents that were always integers, right? Whole numbers. And so we came up with a bunch of rules and we learned that you have a base, you have an exponent, and then the entire thing is a power. And today we're doing the same thing, but we're going to add real numbers, or rational numbers, I shouldn't say real, rational numbers as the exponent. So what happens if you take x and raise it to the power of 1/2? Well, if you draw that, x to the power of 1/2, what does that look like? It starts at 0, 0. It rises very slowly up and to the right. Let's look at some of the points it passes through. It passes through 0, 0. It passes through 1, 1. It passes through 4, 2. It passes through 9, 3. What are these points? These points are the same points as on the square root function, right? So x to the power of 1/2 is the same thing as the square root of x. And that's really the idea that today is all about. The top of your fraction in your exponent, is going to be your exponent. You're raising it to that power. And then the bottom number, you're taking that root. Now, is a really easy example to see where this comes from. Imagine you had x to the 1/2 and you squared it. If you squared it, then you would take the two exponents and multiply them together. When you multiply them together, they become a 1. And we know that x to the power of 1 is x itself. So it stands to reason that what number times itself gives you x? The answer is the square root of x. Right? And so you can see the example here with root 2. If we say root 2 is 2 to the power of 1/2, then we know that if we square both sides, the right side becomes 2, right? And the left side becomes 2, and therefore they're equal, and therefore root 2 is equal to this, 2 to the power of 1/2. Okay? So in general, if it's instead of 1/2, let's say it's 1/3, okay? Then what you do is you get the third root, the cube root. If it's 1/4, you get the fourth root. 1/5, you get the fifth root, and so on. Now keep in mind that this number n, which is the denominator of the fraction of your exponent, has to be a natural number. In other words, it has to be positive and non-zero. So 1, 2, 3, 4, 5. Right? So the exponents we're looking at today are fractions, but the denominators inside those exponents are natural numbers, right? So it's just going to be like a 2 or 3 or a 4 where this n is. And basically all you need to do, you take the denominator in that equation and you place it right there in front of the square root. More often actually it's useful to go from the square root over to the exponential, as you'll see. So here's an easy example. 64 to the power of 1/2 is equal to the square root of 64. We know that that's 8. 64 to the 1/3 is equal to the cube root of 64, and we know that that is 4. Again, if you're not sure, you can just type in your calculator 64 to the power of 1/3. Just make sure you use your brackets, and you get your 4, right? Now, this question I'm going to leave to you. I've posted it on the website. I want to know what's the difference between these two things. How come the bracket around the -4 is important? Okay, so I'd like someone to explain that. If you're at that point now, you can pause and go look and see if anyone's answered it, or you can try to answer it yourself. Why are these two things different? By the way, a lot of marks get lost in this unit because people don't respect this difference. Why is a -4 to the power of 1/2 different than the negative of 4 to the power of 1/2? Again, consider your order of operations, okay? If this question goes unanswered, I will answer it, of course, but I want you guys to try it first. Okay, what do you do when you have an exponent that has a top and a bottom? Okay, so here it's x to the power of m over n. What you get here is the n is the root. It goes at the front of the radical, and m is the exponent. It goes inside the radical. Okay. Now this says where b is not equal to 0. I think probably what it means is x is not equal to 0, and n is not equal to 0. I'm not really sure what this is saying, but b cannot be 0, and n also cannot be 0, right? Because you can't have the 0th root of something. Okay, let's try a couple. So 16 to the power of 3 halves, okay? So that is equal to 16. So let's try and think of it this way. You do a square root, so you do a root sign. You put the denominator number there, which is a 2, and then you put the numerator number inside. Now, it's up to you how you want to do this. You could do the 16 cubed first. If you did that, you'd find that the answer is 4,096. And then you go ahead and take the square root of 4,096, and you get that that answer now is 64. Right? I think I have that right. Yeah, okay. 64. Now that's one good way of doing this, right? That's one particular way you can approach it. Another way you can approach it, since order of operations is about exponents, and the exponent can be done in whatever order that you want as long as you're doing exponents first, what you can do in this question instead is you can do the square root first. So you can do the square root of 16. Square root of 16. Yikes. Square root of 16, and then raise the whole thing to the power of 3. Now the square root of 16 is easy. That's just 4 to the power of 3. And 4 to the power of 3 is 4 times 4 times 4, which is 64. So you're going to get the same answer whether you cube first and then square root, or whether you square root first and then cube. Okay? Let's look at question B and C here. So for B, okay, we're supposed to take negative 27, find its cube root. So I'm going to get in the habit of doing the root part first. So let's do the cube root of negative 27, and then I'm going to square the answer. So maybe I'll just put this in brackets to make it a little easier to understand. Okay, kind of like that. So I'm going to do the cube root first, square the answer. When I cube root this negative 27, I get negative 3 is my answer, because negative 3 times negative 3 times negative 3 is negative 27. Then I have to square this. I don't know why it's not doing that, but okay. Then we know that that answer is, of course, 9. Now again, you can do this all in one step on your calculator, right? You can just go negative 27 to the power of 2/3, and it comes up with 9, right? Okay, what's the next one? 81 to the power of negative 3/4. Okay, now this one's kind of interesting. You have to do, so if the exponent is negative, and then we have to do the 3 and the 4. So what I'm going to suggest here, let's set it up like this. Oops, not that. I'm sorry. We need a radical with an actual number in the front. Okay, the 4 goes there, the 81 goes there, and it's cubed. And then let's put the whole thing to the power of -1. So basically, I'm going to do the -1 at the very end, right? So let's see what this looks like. The 4th root of 81 is 3. So it's 3 cubed to the -1. Right? So remember, the 4th root of 81 is 3, because you basically, to do a 4th root, you can hit the square root button twice. Or you can do 81 to the power of 1/4. And that gives you the answer 3. That's the 4th root. I'll just write it down so we can see it. Okay, so all of those things are equivalent. At the end here, we go 3 to the power of 3, which is 27. To the power of -1, we get 1/27 is our final answer. Now again, you can do this on your calculator. We can go 81 to the power of -3/4, and we get an answer of 1/27, right? Same thing. Just want to make sure you understand the process. Again, this one's a bit tricky. Maybe take it aside, try it on your own, come back and ask questions about it if you need some help. So here's what they're saying. If you see a negative, make it a positive and send it to the bottom. That's also perfectly good. You can do that. Okay? If you see a negative exponent, make the exponent positive and send it to the bottom of the fraction. Put a 1 on the top and you're good to go. Okay, negative 25 to the 5 over 2. Now, in this question, the negative sign, so let's just separate these into different rows. Okay, the negative sign is not in the bracket. So you're going to be doing that negative after you do the exponent, right? So it's like you can try to get in the habit of this. Oops. Typos. Okay, the negative here is going to happen at the very end. So what we're going to do here is we're going to deal with the bracket first. We know that 25, let's try it like this. We're going to write it as a radical. Square root of 25 to the power of 5. Okay, now we know the square root of 25 is 5. So we're going to take 5 to the power of 5 and then make the answer negative. 5 to the power of 5 is 3025, I think. 3125. There we go. And then I have to make it negative because 5 to the 5 is done first, and then the negative sign kicks in. Okay, so again, if I type this into the calculator, exactly as I see it there, negative 25 to the power of 5 over 2, it comes up with the answer, negative 3,125. Be careful with that negative sign. Okay. Okay, 9 to the power of negative 2.5. So 9 to the power of negative 2.5. Okay, let's think of a couple of other ways of writing this. What if I put the 9 to the 2.5 on the bottom and then make the exponent a positive, right? I can do that because I've changed the negative exponent to a positive and I've put it in the denominator. Now I also know that 9 to the 2.5 is also the same as 9 to the power of 5 over 2, right? Because 5 over 2 is equal to 2.5. If you do 5 divided by 2, you get 2.5. And so my whole thing here is equal to 1 over the square root of 9 to the power of 5. Okay? Now the square root of 9, you know that one, it's 3. And 3 to the power of 5, you might not know that one, but you know 3 to the power of 4 is 81. You got to multiply it by another 3, so you get 243, and that's your answer. Okay, again, let's quickly try this one. 9 to the power of negative 2.5, 1 over 243. Again, try this one on your own. Go through what I just did. Why did I change 2.5 to 5 over 2? Why did I change negative 2.5 to positive? And how did it get into the denominator and so on? These are steps you want to make sure you understand so that when you're doing it on your own, you're confident you're able to finish it. Okay? This one here is a little bit trickier. Let's just try and take it a piece at a time. So here what I'm going to suggest is let's take the let's start with changing them into roots. So we have a cube root of 27, and then I'm supposed to take that answer and square it. Then I have subtract a cube root. Oh, sorry, it's a negative, right? So let's put it on the bottom. So 1 over a cube root of 125. And then at the very end, I have a fifth root of 32. Okay. The cube root of 27, you know, is 3. 3 times 3 times 3 is 27. The cube root of 125 is 5. So you know that one. Now you might not know the fifth root of 32. It's 2. But how would we get that if we didn't know it? We could go 2 to the power of 1 over 5. Not 2, excuse me. 32 to the power of 1 over 5. And that gives us the answer 2. So remember, this thing here, a fifth root, you might not have a fifth root button on your calculator, right? So instead, you can raise it up to the power of 1 over 5, right? You can use our rule today in reverse, and that your calculator can do, and then it gives you the answer of 2. Okay, so we have this plus this plus this. So we have 9 minus 1/5 plus 2. 9 minus 1/5, so that's 45 fifths, minus 1/5 plus 10 fifths, and that's equal to 54 fifths. Okay, as we get as an answer for that one. Let's check it. So let's type it in just to get in the habit of doing this. So 27 to the power of 2/3 was the 9. 125 to the power of negative 1/3 is the 1 over 5. And then 32 to the power of 1/5 is 2. So we have A minus B plus C, and we get the 54 over 5 that we thought. Okay, this one. The cube root of negative 343 over 8. Okay, this one you can use an equivalence here. So we're going to say we can make the top and the bottom each a cube root. The cube root of negative 343, and then the cube root of 8. Now, the 343 is a tricky one. You might not know this one. You could try it on your calculator. If you don't, the answer is 7. And it's negative because it's a cube root of a negative, and the bottom number is 2 because the cube root of 8 is 2, right? So if we take this one, we go negative 343 over 8, and then we take that number and raise it to the power of 1/3, we get the negative 7 over 2. So just to recognize, 7 times 7 times 7 is 343, and if the 3 7s are negative, then the answer would be negative. Okay, here's an important type of question to know. I always ask this type of question. So, write as a single power. So this is my way of kind of getting around the fact that your calculator can answer a lot of these questions. I want to know that you can answer the question, not just that you know how to plug it into a calculator. So what you're trying to do here is figure out how to write this as one number with an exponent. So what I'm going to do here is I'm going to do what we just did in reverse. Okay, so I'm going to say the top is 24 to the power of 1/3, right? Instead of cube root, I write 1/3. The bottom is negative 3 to the, Okay, the bottom is negative 3 to the power of 1/3. Now what I can do is I can take those two 1/3s and combine them, like that, right? Since, it's a power on the top and the bottom, could be the same thing as a fraction to the power. Then what I can see is something I probably couldn't see before. 24 divided by negative 3 is negative 8. I can do that, right? And then I go to the power of 1/3. And then I get the answer is negative 2. Okay, so this type of work is really important because you'll look at a question like this one, you'll think, I don't have no idea how to do that. But yet if you know your steps, you can work your way through and do it in your head. You don't even need a calculator to answer a question like that. I want you to try to answer these ones and and do it the way I'm doing it, because these are the ones where I'll probably be collecting your work or looking for you to show me how to write it in this format. Express your answers in rational form means basically no decimals, right? Leave it as a fraction. Again, that's so you prove to me you actually know what you're doing and not just using your calculator. Okay, here. The 5th root of 16. Okay, now let's try and write this one out. See if we can come up with a way of doing this one. So the 16 just trying to think if this is the easier way of doing this, or we should do it somewhere different. Let's use an idea here that 16 is equal to 2 to the 5. 2 to the 4. Okay, so let's use an idea. This is a change of base idea. 16 is 2 to the 4, and 4 is 2 to the 2. Okay, so what I'm going to do in this question is I'm going to take all these different bases and write them all using only 2. So for example, the first part I'm going to say is the 5th root, not of 16, of 2 to the 4. Okay, because I replaced its 16 with 2 to the 4. Then the second part, I'm going to take this root. It's the 5th root of 4, which we know is 2 squared. Okay. On the bottom, we have the 5th root of just 2. Okay. Now, since they're all 2's, I can do some stuff to combine them together. Let's write them as fractions first. So the 2, it's raised to the power of 4, and then you take the fifth root. Okay? The second part, it's 2 raised to the power of 2, and then take the fifth root, right? And then the bottom is 2 raised to the power of 1, and then with the fifth root. So we have this. Now, what do you do when you have three bases that are all the same? The two on the top, when you're multiplying them, you go ahead and add them. You add their exponents. Okay? So here we have 2 to the power of 4/5 plus 2/5. And on the bottom, let's deal with the bottom in a second. Deal with the bottom in a moment. Okay? Now the top, you can go ahead and add. So just put a fraction. Okay, 2 to the power of 6/5. And on the bottom, we have 2 to the power of 1/5. Now what am I supposed to do when I have two powers with the same base, one on top of the other? I take their exponents and subtract them. And we get 2 to the power of 5/5, which is 2 to the power of 1, which is 2. Okay? So again, this is a tricky question. It takes a lot of knowledge to be able to do something like this. So, take your time, do your practice, reach out if you need something. But understand that the only reason I could do this question is because 16, 4, and 2 can all be expressed as powers of 2. And that's really the thing I want you to concentrate on. How do I take all the numbers in the question and write them all using the same base? Okay? Now you can see in this question they're already in the same base. In this question they're already in the same base. But in this question they're in different bases. Right? So let's try to finish this one off, and then I'll leave you some time today because you're going to need some practice just working on the book and stuff. So write as a single power. Okay, I'm supposed to take 9 to the power of 1/5 and multiply that by 9 to the power of 0.3. Well, I know that when you multiplying powers together, and by the way, 1/5, let's just write this down on the side, 1/5 is 0.2. So 9 to the power of 0.2 times 9 to the power of 0.3 is equal to 9 to the power of the two numbers added. Right? Which is equal, you know how to add 0.2 and 0.3, it's equal to 0.5. And now you see something that you couldn't have done at the beginning, is that 9 to the 0.5 is the same thing as 9 to the power of 1/2. And we know that 9 to the power of 1/2 is actually just the square root of 9, which is a number right? The answer is 3. Right? So again, really, really good question here, just to take something complex and turn it into something simple. Let's try this one with 16. Okay, so 16 to the negative 2.5 to the negative 0.2 over 16 to the 3/4. Okay, so what do I do with the first part? When you have a power to another power, you multiply the powers together. So you multiply those two numbers up at the top. Okay, then we're going to divide this by 16 to the 3/4. Okay, what does this do? When you multiply negative 2.5 times negative 0.02, you get a positive 0.5. Okay, now let's change the bottom one into a decimal as well, just to make this a little bit easier. 3/4 as a decimal, we know, is 0.75. And two numbers, when you subtract them, when you divide them, you just subtract their exponents. Now what the heck is 16 to the power of negative 0.25? Well, we know that it would, whatever it is, it would be equal to 1 over 16 to the power of positive 0.25. And I know that as a fraction, positive 0.25 is actually, as a fraction, is 1/4. So really what I'm asked to be doing here is, what is the fourth root what is the fourth root of 16? Now again, you may not know this yet today, but hopefully you'll do enough of these questions that you're going to come to realize the fourth root of 16 is 2. right? Because 2 times itself 4 times gives you 16, right? So you end up with this answer 1/1/2. Okay? Again, good question. Take it aside, try it again, see if you can get to 1/2 from the beginning without a calculator. Right? See if you can go through this. That's what you should be testing yourself to see if you understand what we're doing today or not. Okay, let's try this last one. It's pretty tricky, but it says 1/16 to the power of 1/4 minus 8/27 cube rooted is equal to the square root of x squared. Okay, well, first of all, 1/16 to the power of 1/4, right, minus, let's change this to an, let's just write out the question the way it is first. So cube root of 8/27. And of course on the other side, it's just equal to x, right? Because you're square rooting, you're taking x squared and square rooting it, right? And really we should say plus or minus x, but let's do that after. We'll do plus or minus. Okay, never mind. We'll do plus or minus. We'll do it right. Okay, so plus or minus x. We're not sure if it's positive x or negative x, right? Because when you square root x squared, let's say x is, -4. You know what? Actually, I'm wrong. You only get the positive x. Sorry. So because the root, right? We're taking the root of x squared. So even if x is -3, when you take the square root of -3 squared, you're going to get the positive. It's not really clear from this if it's the function where I only keep the positive, or should I keep both. Let's come back to it. Let's put plus or minus for now, and we'll come back to it and see if it makes sense as an answer when we get to the end. Okay, so what I have to do here is I need to get 1/16 to the power of 1/4. So I know that if I do this, it's 1 to the power of 1/4 over 16 to the power of 1/4, right? I can sort of distribute, in air quotes, the 1/4 to the top and the bottom, and what I get there is 1/2, because I know that the fourth root of 16 is 2. We just looked at that one. So that first part really simplifies down to 1/2. The second part, okay, is the cube root of 8 divided by the cube root of 27. So again, let's do the separation. So cube root of 8 divided by, of 27. And that one isn't too hard either. We know the cube root of 8 is 2 and the cube root of 27 is 3. So what you're getting here is that 1/2 minus 2/3 equals plus or minus x. And therefore, what's 1/2 minus 2/3? It would be 3 sixths minus 4 sixths equals plus or minus x. And -1/6 equals plus or minus x. And therefore, x equals 1/6 or -1/6. It could be either the positive or the negative. Let me see if this makes sense. Let's test it. So let's draw this here. So let's type it in exactly as it looks like. So 1/16 to the power of 1/4 subtract cube root CBRT 8/27 equals square root of x squared. Well, it didn't know what to do with that, so let's try it another way. Let's say, so let's copy the same thing out. So we get this, right? So this is the -1/6 we had before. So -1/6. So if I take 1/6 and square it and then square root it, it's interesting. But if I take -1/6 square it, and then square root it, I also don't get that answer, right? Okay, so both of these are in fact answers, but the root that we're taking is the negative root. So I don't really like this question just because I think it's adding a number of confusing elements. I think I'm going to leave it because what we did is technically right, but I'm going to say don't worry too much about this question because basically what it's doing, it's asking you when is square root x equal to square root x squared equal to negative 1/6. And it isn't, right? Because square root of x squared gives you the absolute value function. Well, we also know that square root sometimes means the negative square root, right? And then you can see that, yeah, there are two answers. So y is equal to negative 1/6. And you can see there are two answers, one at positive 1/6 and one at negative 1/6, right? So positive 1.666 is my answer there, and then negative 1.666 is my answer there. Now again, this is true, but it's not really the focus of our attention here. If you just followed the steps and were able to show that 6 or 1/6 or negative 1/6 is the answer, that's enough. But even that, honestly, I don't think is the main thing today. I would concentrate on the questions above it. Okay, so again, if you want to ask about this one, I'm happy to try to field questions about it, but again, don't worry too much about this because it's the question isn't really that well formed. Okay? Anyway, let's stop there for today because you got some practice you need to do. Again, try the question I post on the website, and if there are any other questions, please post them to the discussion area.